Multiple representations assessment review number 2. You should have this worksheet in front of you. If you don't, go ahead and copy down this problem. Your worksheet says 2,300 feet. I want you to change that to 2,100. So, an airplane has reached an elevation of 2,100 feet above sea level. It is descending. That means it's going down at a rate of 70 feet per minute. 70 feet per minute is the unit rate of change. So for every 1 minute, it goes down 70 feet. So I'm going to write down 70 feet per 1 minute. That is our unit rate of change. Now, that means that we have two variables. We have feet and we have minutes, and we need to decide which one is the independent and which one is the dependent variable. So whenever you're working with time, time will usually be your independent variable. So it's minutes, that's your independent variable, and therefore your dependent variable will be feet. That's why. Because the minutes determines the number of feet that you are descending. So now the next thing that you need to do from here, instead of drawing a table, I usually find it easiest. So now after we have our equation, we can go back to our table of data. And I have not asked you to find certain values of x. So we're just going to go minutes, and then y is going to be feet. And then in the middle, I'm going to put y is equal to 2,100 minus 70x. So in this situation, let's just go ahead and find out after 0 minutes where the airplane is after 1, 2, 3, and 4 minutes. All right, so, and oftentimes I'll put my work here in the middle, or my process. So, we're going to take our equation 2,100 minus 70 times 0 minutes means that it's at 2,100 feet. Okay, 2,100 minus 70 times 1 minute is just going to be 2,100 minus 70, which is 2,030 feet. Then 2,100 minus 70 times 2 minutes. And basically, we're just subtracting our unit rate again, so that is 1,960 feet. Then 2,100 minus 70 times 3 is going to be 1,890 feet. And then 2,100 minus 70 times 4 minutes would be 1,820 feet. So now we can use the information in our table to graph. So these are, let's see, these are our x values and these are our y values. So what you'll want to do is go back and go ahead and set up your table. I mean your graph. The equation. So let's look at this equation. It says write an equation to represent this situation. So y, which is our current level, is going to equal 2,100, that's where we started, minus 70, that's our unit rate, times x number of minutes. So let me go ahead and mark what each of these mean. So y would be our current feet. 2,100 is going to represent our start. And then 70 will represent our feet per, and then let's look at x is the number of minutes. So our current elevation, or the current feet, is 2100, our starting point, minus 70 feet per number of minutes. All right, so now we have to use that equation to find out how many feet the airplane has descended, and I left out a word here, so I just want you to write to, descended to, after 5 minutes, 15, and 25 minutes. So let's write the equation. Y equals 2100 minus 70 times the number of minutes, and in this case, instead of x, we're going to go ahead and substitute in 5. Now remember, according to order of operations, we always have to perform multiplication and division before we add or subtract. So we're going to do 70 times 5, and then we're going to subtract that from 2100, and that leaves us at 1,750 feet. So after 5 minutes, the airplane has descended to 1,750 feet. Okay, now let's look at y at 15 minutes. So y equals 2100 minus 70 times 15. Okay, so we've got to do 70 times 15 first, which is 1,050, and then we subtract that from 2,100 and we get 1,050 feet again. So after 15 minutes, the airplane has descended to 1,050 feet. Now let's look at after 25 minutes. That'll be 2,100 minus 70 times 25. So, okay, so that's going to be 2,100 minus 1,750, and then we have to subtract that from 2,100, and we get 350 feet. So after 5 minutes, the airplane is at 1,750 feet. After 15 minutes, it's at 1,050 feet, and after 25 minutes, it's at 350 feet. All right, so I have already set up my graph. Notice I have, let me use my laser pointer. Let's see. Oh no, that's not my laser pointer. Okay, found it. So notice I have a title for my graph. I also have labeled my y-axis and my x-axis, and then I have labeled my intervals. So here I chose to go, because my graph is really small, so here's 100, 300, I'm just noticing something, 100, 200, yeah, 500, 700, so on, and then I just went by 1, 2, 3, 4, 5, 6 minutes. Now 2,100 is not actually on my graph. So what I'm going to do then, and that's fine. So what I'm going to do is after 0 minutes, my airplane is at 2,100 feet. After 1 minute, my airplane is at 2,030 feet. So that's going to be about right there. After 2 minutes, my airplane was at 1,960 feet. So we're going to go with about there. And after 3 minutes, it goes down again to 1,890. So around there. And notice what is happening is that it is decreasing by 70 feet every time, as every minute passes. So I can continue to draw out my data. That is fine. But what I want you to notice is that we are going to have a linear situation. And if I had a nice straight edge and I had completed all of this, we would see a straight line going down. So this is a linear situation. It is non-proportional because it does not go through the origin. And this does represent continuous data, remember, which means that we can connect the lines because we do have values between each of our increments. So between 0 and 1, there are certainly 60 seconds that the airplane is going down. So we can have partial minutes. And that is it. So I want to make sure that you study, that you can take these situations just like the situation that I showed you, and I want you to be able to represent it in all 4 ways. So watch, rewatch until you really understand, because hint, this is really going to help you for your quiz tomorrow.